Okay, class, thank you for joining me today. We're going to start with some questions in Learning Module 5D, particularly question number 5. Okay. Okay, so in order to add and subtract like terms, they need to have two things in common. They need to have the variable, and they also need to have the exponent in common. These two things need to be the same if you're going to add or subtract the terms. Okay, so in this problem I can see that I have 3 terms, 3 separate terms. The first term is a positive term and the second and third term are both negative. I can see that they all have the same exact variable, and that variable also has the same exact exponent. So that means that I can go ahead and add and subtract these. Typically what I do is I grab the terms that have the same sign, for instance -3 and -11, because since they're the same I'm going to go ahead and add them together. And I'm going to get -14W. And then all I have left is the positive one. So here I'm going to subtract, and when you subtract, obviously you take the sign of the largest number, and you're left with -9W. I'm going to go ahead and type that in. -9W, preview it, and submit. And there we go. Did you have any questions about that one? Did you want me to do another one just like it? Was it because it was a W? It doesn't really matter which letter they use as long as they match. So this time they chose to use an X. And again, I like to grab the ones that have the same sign. Since these are both positive, I'm going to go ahead and add them together to get 16X. Then I have -7X. And again, that we do get a 9X, but we get a positive 9X this time. And I'm going to type that in as well. 9X. Okay. Do you want me to do any more from this section, or would you like me to go to another section? I'm going to go ahead and do this one. So here in this problem, we're going to distribute the -6 to the 9X and the -2 by multiplying. And then we're going to distribute the 3 to the 8X and the -8 by multiplying. So first I'm going to get -6 times 9X, which is a -54X. And then -6 times a -2 is a +12. Then I'm going to take the 3 times the 8X is going to give me a +24X. And then a 3 times a -8, which is a -24. And again, at this time, you look for like terms. I can see that -54X and +24X is going to combine to give me a -30X. And then I'm going to take +12 and -24, and I'm going to be left with a -12. So I'm going to go ahead and type that one in. So I have -30X -12. I'll preview it, and that looks good. Okay, I'm just going to skip around through some of these sections unless you have any more specifics. If you do, just go ahead and type them in the box. I can see it while I'm still going, and I'll get to them as I go. Okay, this one is pretty much the same thing we've been doing. It's combining like terms. I can see here that it does have those two characteristics. It has the same exact variable as well as the same exact exponent. They both have a y that also have a cubed. So I'm going to combine the coefficients, which is -7 and a +3, which is going to give me a -4. And since y cubed is what made them the same, I'm going to keep that. Nothing changes about the part that makes them like terms. So what I'm going to actually select the third one down and submit. Okay. I'm going to skip down a little more. This is just like distributing. We did it just like that in the previous professor. Negative 9q through 7 times 7p. The 9 and the 7 give me the negative 63. And p and q, I'm just going to go ahead and rewrite that. I could also write qp. These would be equivalent answers. I'm actually going to type one of those in. I'm going to type the first one in, minus 63 PQ. I'll go ahead and preview it. And there we go. And let me just check the last problem in this section. Okay. So I'm just going to type this in. Okay, there we go. So you can see in that question, it's just asking you to combine like terms. Associative property has to do with the addition, so my 8 and my 11 give my 19. So you're just writing the expression as you can, with simplifying as much as possible. So let me go to another section. I'd say let's go to chapter 6. Okay, chapter 6 is all about equations. That means you're working with the equal sign and trying to get the variable by itself. So let's skip through a couple here. It says solve the equation x plus 20 equals 6. And basically what it's asking you is, what does this number have to be for the final answer to be 6? And we can follow our rules of equality to do that. Now this problem, since it's so small, you could figure it out in your head, but for future problems you want to know the same exact steps. So technically I want to get this variable all by itself. And in order to do that, I need to get rid of this positive 20. So what I would do is I would take minus 20. And whatever you do on one side of the equation, right, which is this side, you also have to do on this side. So what happens is these cancel to give me 0. Then I have x equals, and when I combine these terms here, I'm going to get a negative 14. So I'll go ahead and type that one in. Okay, there we go. And I'm just going to keep skipping around here. Same thing on this problem. You want to use the rules of equality. You always use the opposite operation to move a term from one side to the other. So again, if this is my variable and this is the one that I want to get by itself, I have to get rid of this 4. Since the 4 is being added to the b, the only way to get rid of it is to do the opposite, which is minus. Now again, whatever you do to one side of the equation, you have to do to the other. You got to keep it equal, keep it balanced. This cancels. I'm left with equal signs. The b comes down. The 12 and the minus 4 give me a positive 8. 8 equals b is the same exact thing as b equals 8. Okay. Again, if you want me to skip to a different section or do a particular problem that maybe you're struggling with, just let me know. I did open up learning module 5, 6, 7, and 8 for homework only through May 2nd. So if you didn't get to it, you can try to get to it now. These are all pretty much the same. Here's a different one just because it has a negative number there. But we're going to follow the same exact rules. In order to solve for x, I need to get rid of this positive 1. The only way to do that is to subtract 1. Whatever you do on one side, you have to do on the other. That cancels. x equals a -6, because these have the same sign, you are going to take the sum, which means to add them, and that's how we got the 6. Okay? We'll do this one too. Same exact rules we've been following. My job is to get the letter, the variable, all alone. To get rid of the +7, I'm going to do -7 on both sides. Here I'm going to subtract because they have different signs. So I'm going to get a 3 equals r, and again that is the same thing as r equals 3. We will also do this last problem here. I have v -7 equals 8. Again, it doesn't matter what letter they give you. A letter is a variable. We're just used to seeing x and y the most. Don't get thrown off by the different letters. My job is to get this v by itself. So I'm going to get rid of this -7 by making it a +7. And again, you always want to do that on both sides of the equal sign. So I get the final answer of v equals 15. Let me go back and grab some from the next section. Did any of you have any questions so far? Okay. So this problem is dealing with the properties of multiplication and division as far as solving equation goes. So just like with addition and subtraction, we always did the opposite. We're going to do the same thing here. I cannot consider this equation solved yet because the variable t is not by itself. It has this negative sign here. And since this negative sign is the same thing as having like -1, it's like -1 times t. Well, the opposite of times is division. So to get rid of that negative sign, I can divide by -1 on both sides of the equation. That will cancel and leave me with a positive t equals a -8. And our job, again, we want that variable to be alone, and we also want it to be positive. That's how we know we are finished solving it. Okay? And again, I'm just going to skip around and go to questions that I see being typed in the chat box. Okay, I like this one. Now this one also has a little video just in case you get stuck. So here it is combining a lot of the different rules that you guys have learned and probably remember from before. So here my variable is x, and I'm going to just change my color. So this is what I want to get alone, okay? So I'm going to get rid of this -6 at some point. But first I want to simplify this side as much as possible. I can see that I have -3 minus a -2. Already I know that this minus makes this minus a positive. So really it's -3 plus 2. I also know that -3 plus 2 is really just a -1. So I'm going to bring the rest of the equation down. I'm actually going to rewrite it down here. X divided by -6 is equal to -1. Now again, my job is to get the variable all by itself. So what I would do here is I would do the opposite of this number. Since I want to get rid of -6, and -6 is being divided by here, the opposite of division is actually multiplication. So by multiplying by that same exact number, whole number, right? A whole number is over 1, and that's how it's able to cancel out when the number is in the denominator. I'm going to do the same thing on the other side. I'm left here with a positive x, which is what I want, and a negative times a negative is a positive. Any questions about that one? Okay. Just going to keep going. This is exactly like the problem we just solved, except it's a lot smaller. In order to get rid of this denominator, we're going to multiply by 6, do the same thing on both sides, and I get d equals 54. That's exactly the same thing. And I'll go ahead and do this one too. So here we have the x divided by a -4 equals -10 minus a -3. Again, that negative in front of the -3, that negative makes that negative a positive, so really it's -10 plus 3, and those two together give me -7. Bring down the x over -4, and then my job is to get rid of the -4. I'm going to get rid of the -4 by doing the opposite of division, which is multiplication. I'm going to do the same thing on both sides. It's going to cancel and leave me with a positive x equals a positive 28, because a negative times a negative is a positive. Okay. Just going to go to the next section. Okay, so here we have basically just more positive and negative numbers, but we don't get thrown off by that. Just take your time and use the rules that you know. Again, my job is to get the variable all by itself. So first I'm going to get rid of this -3 by doing +3. And what you want to do is you want to get rid of the term that's further away from the variable. And technically this 3 here is being multiplied with the variable. It's very, very close. This -3 is a little bit further away. So I'm going to get rid of this first, and then I'll get rid of the thing that's closest to it very, very last. And that's typically the division part. So again, whatever you do on one side, you do on the other. So I get 3x equals a -3. And again, to get x by itself, I'm going to do the opposite. X is being multiplied by 3, so the opposite of multiplication is division. I'm going to be left with x equals -1. Same thing on this exercise. Here, I have a -5x minus 8 equals 22. Again, I'm going to get rid of the term that is furthest away from the variable, which is the -8. I'm going to do that by using the opposite operation, which is positive. I'm left with -5x equals a 30. And again, using my opposite operation, -5 is being multiplied by x, so the opposite of multiplication is division. So I'm going to divide on both sides, and I'll be left with x equals a -6. This next problem is exactly the same thing. They just flip the sides, and that really isn't a big deal. -16 equals 2x minus 8. So again, if I had to choose between the 2 and the -8, on which one am I going to get rid of first? I'm going to get rid of the -8 by doing +8. So I have -8 equals 2x, and 2 and x are being multiplied. So the opposite of multiplication is division. Divide on both sides, and I'm left with -4 equals x. Equals x, which is the same thing as x equals -4. Any questions about those? Alright, this one's just a little bit longer, but it's not really a big deal. What we want to do is just follow the same exact rules that we've been following, and that will be it. So I'm just trying to change my pen. Here we go. So I have -12 times x plus 5 plus 516 equals 15 plus 21. And again, your job is to get the variable all by itself. So we're going to have to distribute, combine like terms, and use our properties of equalities to finish this problem. First, I'm going to combine these two, 15 plus 21, to get 36, because I want to simplify each side of the equation as much as possible, combining like terms, okay? And I can't combine like terms until I distribute on the left-hand side. So I'm going to get -12x, and then 12 times 5 is 60. So I'm going to get a negative 60 plus 516. And then again, I'm going to look for my like terms, and I can see that 516 and 60 can be combined together. I'm going to subtract them because they have different signs to get 456. And it's going to be a positive 456 because that's the highest number. Bring down the minus 12x equals 36. And now I'm going to start using my properties of equalities to move my terms from one side to the other. So I can see that, let me move my screen just a little. I can see that in order to get rid of this positive 456, I'm going to have to subtract 456 from both sides. So when I go to the other side, I'm going to end up subtracting because those numbers have different signs, right? 456 is negative, 36 is positive. So I'm going to subtract those and get a minus 420 equals, those cancel, and I'm going to bring down the minus 12x. I have one final step, and that is to get the variable all alone by doing division. So I'm going to do, in order to finish the problem, I'm going to have to divide by negative 12 because I want to get this x all by itself. And since I divided by negative 12 on that side, I'm also going to divide by negative 12 on this side, and I'm going to get x equals a positive 35. Right? Yes. All right, cool. All right, I'm just going to keep going. Okay, this is basically the same exact thing but with decimals, so we'll just do a few. This is all about you remembering to line up your decimals when you do your work because, again, you're not using a calculator. So I'll just rewrite this problem. So here, again, I want to get my W by itself, and I'm going to use the opposite operation to do so. I have 15.7 on one side and 13.2 on the other. So what I need to do is get rid of this 15.7 by doing subtract 15.7. I'm going to subtract 15.7 on both sides of the equation, and I'm going to get W equals a negative 2.5. Now again, you're doing this by hand, and by hand you can't work this problem like this. You're going to have to rewrite it to actually do the subtraction by hand so you can get the 2.5. And again, you always take the sign of the highest number, which in this case was negative. And we'll just do one more and then we'll move on because this is all about doing the same exact process we just did with whole numbers, but also doing it with decimals. Okay, where's my pen? Here we go. So I have 2a plus 5.5 equals 18.7. I want to get this a by itself, so I'm going to get rid of this 5.5 first by subtracting 5.5 on both sides. So I'm going to have 2a equals, my sign is going to be positive because the 18 is bigger, and I'm going to get 13.2. Now I need to get a by itself by dividing by 2. So I have to do this division. So it's 13.2 divided by 2. I'm going to go ahead and put my decimal up in my answer. 2 cannot go into 1, but it can go into 13 6 times, which will give me a 12 and a remainder of 1. Bring down my 2. 2 goes into 12, again, 6 times. And again, I already put my decimal in my answer, so now my final answer is 6.6. Okay, let me just go to the next section. Okay, here I suggest using the technique of clearing fractions. It is a lot easier to solve equations that have fractions when you take the time to actually get rid of the fractions. And how you get rid of the fractions is actually by looking for a common denominator. So I can see here my denominators are 5 and 4. If I was going to try and make them have a common denominator, I would make them 20. So what I'm going to use is instead, I'm going to multiply the entire equation by that same exact number. So when you choose the number that you're going to multiply by, look at the denominators that you have. So here, what I'm going to do is I'm going to get 20 over 5x plus 20 over 4 equals, and 20 times 2 is 40. And as you can see, what's going to happen is each one of those fractions is going to simplify down to a whole number. 20 divided by 5 is just 4x. 20 divided by 4 is just positive 5. And my 40 is already a whole number. Now that I did that, I can start solving without dealing with the fractions. I'm going to subtract by 5 to get 4x alone. So I get 4x equals 35. And then my last step is to get the variable alone. It's okay to leave your answer improper as long as it is simplified as much as possible. And it says you can enter your answer as an improper fraction just like this. So I'm going to go ahead and type this one in, 35 divided by 4. There you go. I'll just do a few more. Again, practice makes perfect. Now this problem looks a little different because it only has one fraction, but I'm going to just go ahead and do the same thing. And there's a couple different ways you could do this, but I'm just going to do the same thing. Why make it difficult? Why change what I'm doing? So here I only have one denominator, which is 7. So I'm going to multiply everybody by 7. So I'm going to get 56x over 7 plus 35 equals 28. I just went ahead and took that 7 and multiplied it by everyone. And again, this is going to simplify. I'm going to get 8x plus 35 equals 28. I want to go ahead and get the x by itself. So first I'm going to get rid of the 35 by doing minus 35. So I have 8x equals, I'm going to take the sign of the largest number, which is a negative. And the difference between 28 and 35 is 7. To get x by itself, I'm going to divide by 8. So my final answer is x is negative 7 over 8. And I'm going to go ahead and type that in just so you can see how to type it in without a problem. Okay. Okay, so here we go. Let me change my color. I have W minus 2 over 7 equals negative 3 over 8. That's kind of sloppy. Let me do that one more time. Erase. Okay, W minus 2 over 7 equals negative 3 over 8. Okay, same process here. I want to get rid of these fractions. I can do that by multiplying the entire equation by the common denominator, and I can see out of 7 and 8, the common denominator will be 56. So here I'm going to multiply 56 by every single term in the original problem. So I'm going to go 56 times W, 56 here, and 56 to the last one. So here I'm going to get 56W minus 112 over 7 equals, and then 56 times 3 is going to be a negative 168 over 8. So now I want to go through and simplify these fractions. So I'm going to do 112 divided by 7. It's going to give me a 16. And then 168 divided by 8 is going to give me 21. So my new equation, I'm just going to come up here, is going to be 56W minus 16 equals a minus 21. Again, my numbers here were negative. In order to complete this problem and get W by itself, I need to go ahead and move the negative 16 by doing positive 16. That cancels, leaves me with a 56. W equals, these signs are different, so I'm going to subtract, and the difference between 21 and 16 is 5. To get W by itself, I need to divide by 56. I cannot simplify that fraction anymore, so I'm going to go ahead and type that in. 5 divided by 56. I'm going to preview it and submit. Oh, it didn't like me. Did I miss something? Did you catch it? Let's reattempt it. Will it give me the same one? Oh no, give me a different one. Let's do this one again. Did I miss the instruction? Write your answer as a reduced fraction. Okay. Let me do it again. No, I want to erase. Okay. Okay, so let's do this one more time. We have K minus 6 over 7 equals minus 9 over 2. And again, to get rid of these fractions, I'm going to multiply the entire problem by a common denominator. The denominator 7 and 2, I would use 14. So I'm going to have 14K minus 14 times 6. So I'll go ahead and do that over here. So 4, 24, 6, 7, 8. So I have 84. It's 84 over 7 equals, it's going to be a minus sign, and 9 times 14, I'll do that over here as well. 6, 36, 9, 10, 11, 12. So a negative 126 over 2. Now again, I should be able to simplify these, and they should give me whole numbers because that is the point of what we're doing. And 84 divided by 7 is 33. So I have 14K minus 33 equals half of 126 is 63, and it's going to be a minus 63. Next, I'm going to move the negative 33 by doing plus 33. That cancels. I'm going to come up here, so I'm left with 14K equals 63, and 33 is actually going to give me a minus 30. Then I'm going to divide by 14 to get K by itself. And I need to make sure I simplify this. So off the top of my head, really quickly, I would say they're both even. So if I cut them both in half, I'm going to get negative 15 over 7. And this should be a good answer. So I'm going to go ahead and type that in. Minus 15 over 7. There we go. Submit. What is going on? I am guessing that there's just something wrong with this question because I know that's not incorrect. So I'm going to go ahead and move on to another one and write that down. What is that? Number 8. 6E, number 8. Okay, I'll make sure I go fix that so that no one is getting marked incorrectly for it. Number 8. Okay. Let me see what time it is. Alright. Let's see the last one. Okay. This is a good one. So here, the only real difference to this problem is that it gave me 2 variables. But again, we're going to go through the process of getting rid of those fractions so that we are dealing with all whole numbers, and it'll be a lot easier to see. I can see that this problem, I have the denominators of 3, 6, and 6. So what I would do is multiply the entire equation by 6. I'm just going to change my color. So I'm going to get 6y divided by 3 plus 6y divided by 6 equals 30 over 6. So here I'm going to get 2y plus 1y equals 5. If I combine the 2y and the 1y, I'm going to get 3y equals 5. And I'm going to divide by 3 to get the y by itself. And again, I'm going to go ahead and type this in. 5 divided by 3. Submit. Okay. Go to the next one. That was E. Some water. Was EF. Okay. All right. So basically, we're going to do the same exact property, use the same exact properties we've been using. The difference is this time, the variable that we're solving for is not all in one place. They actually put one on each side of the equation. All that means is that as we're adding and subtracting and multiplying and dividing to move terms around, I'm going to move this term over here, and I could very well move the 5x to the right hand side. I just typically like to move the variable to the left. That's just where I like it. So I'm going to actually move it by subtracting 3x. Now take note, I am subtracting because I am picking up the entire term. Later on, when I'm almost done, I will divide these to separate the number from the variable. But right now I want to move the entire term. So I'm going to be left with 2x plus 4 equals 10. Then I'm going to subtract by 4. So I have 2x equals 6. Then I'm going to divide by 2 to get x equals 3. Same exact technique here. I want to make sure I get all my variables on one side of the equation and all of my numbers on the other side of the equation. So again, I'm going to move the 3x over by doing minus 3x. Again, I'm going to get 2x plus 7 equals a negative 7. I'm going to get rid of the positive 7 by doing minus 7 on both sides. 2x equals a negative 14. Divide by 2, x equals a negative 7. So again, over and over, I'm just using the opposite operation to move terms around. Okay, in this problem, they give us a little more simplification to do before we can actually start solving. And this includes distributing. So I'm going to distribute this 8 to this x to get 8x. Then I'm going to distribute this 8 to this negative 7, which is negative 56. I'm going to bring down the negative 4 because I'm not actually distributing that anywhere, or it's not getting anything distributed to it. Bring down my 20x minus my 120. Again, before I actually start solving, we want to just simplify as much as possible. Negative 56 and negative 4 give me a negative 60. I'm going to bring down my 8x equals 20x minus 120. I want to start to move my variables to the left, so I'm going to do minus 20x. It's going to leave me with a negative 12x minus 60 equals minus 120. Then I'm going to get rid of the minus 60 by adding 60. Leaves me with a minus 12x equals a minus 60. Last but not least, I'm going to divide by a negative 12 on both sides, and I'm going to get x equals a positive 5. I'm going to do one more from this section. The last one. It's usually a good one. Well, that's an easy one. Let's do this one. Okay. Any sections you guys want me to go to before I end today's session? Probably going to end it after this question. So I have 8x minus 10 equals 7 times x plus 4 plus 5. So again, before you can start solving, you really have to make sure everything on the left is simplified and everything on the right is simplified before you start moving things around. And I can see my left hand side is good to go. There are no like terms, there's nothing to distribute, nothing like that. But on my right hand side, I do have some distribution, and after that, I'm sure I'll have to combine like terms. So I'm just going to bring down the 8x minus 10 equals 7 times x is 7x, 7 times 4 is 28, 5 is just going to come down. Again, I have to combine like terms, so I'm going to combine the 28 and the 5. Since they're both positive numbers, I'm going to add them together. And I'm going to add them together to get a 33. I'm going to bring down everything else. Bring down my 8x minus 10 and my equal sign. And now I'm going to work on getting all my variables to the left-hand side by doing minus 7x. It cancels it from the right, leaves me with just 1x minus 10 equals 33. And then I'm going to continue to get my variable x by itself by adding 10 to both sides. Leaves me with x equals 43. Any questions so far, guys? Okay. Do you want me to go to the next section? Okay. Alright, well, if you guys don't have any more questions, I'm going to go ahead and end today's session. And I'll start to look to see when the next session will be. Again, I left Learning Module 5, 6, 7, and 8 homework only opened all the way through May 2nd, so to give you guys a chance to get as much of it finished as possible. You're welcome. Please let me know if you need anything. I'm going to be looking at some of the grades today. I'm probably going to drop the lowest grade of some assignment. I'm not sure which one. And don't forget, we got to take the final by the end of the semester. It is a big portion of your grade. You can pretty much pass the whole class just by passing the final. So make sure that's on your mind to start preparing now and not at the last minute.